Today we're going to be looking at some testing we've been doing around the ability to make 3D printed nylon 12 ESD safe for use when nesting electronic components like a PCB board. Just so we're on the same page, ESD stands for electrostatic discharge, which is the sudden flow of electricity between two electrically charged objects caused by contact, an electrical short, or dielectric breakdown. In order to prevent damage to electronic components, the material that is used to hold them must be ESD safe. To test if a material is indeed ESD safe, we need to measure the surface resistance of that material. A surface resistance that is too high allows for a static charge to build up and cause potential damage to sensitive electronic circuits. A surface resistance that is too low can cause unintended conductive paths between test points and produce crosstalk when testing electronic components. The proper range for surface resistance is between 10 to the 6th and 10 to the 9th ohms. In order to conduct this testing, we used a surface resistance meter. We ended up testing 3 different materials along with 1 coating. We started out by testing a control material, which was a sheet of nylon 6/6, which is known to have a high surface resistance that would be greater than 10 to the 12th ohms. This makes it not well suited for ESD safe applications, as shown here. Next up is a sheet of nylon 12 that was printed on our HP MJF 4200. As with the nylon 6/6, it is proving to have a high surface resistance and due to that fact is not ESD safe. There are coatings available that can be used to give the surface of a part the desired ESD safe characteristics we are looking for. For this test, we used TechSpray's Lycron Crystal Spray. Per the manufacturer's instructions, it was applied to a printed sheet of nylon 12. We found that the treated sheet of nylon 12 had a uniform result of 10 to the 9th ohms over the entire sprayed surface of the part, which puts it in the category of an ESD safe component. As an added bonus, we also tested a sheet of 3D printed ABS ESD7 that was printed on an FDM machine. This is a standard ESD safe material for the 3D printing industry. What we found was really interesting. While the center of the part was shown to be ESD safe, the outer edges were not. Upon further investigation, we found out that infill density, layer orientation, and the mode that the support was printed in all play a large part in how conductive an FDM ESD safe component ends up being. So, why should you take my word for all of this? Well, you don't have to. Everything I showed you here today was actually just a recreation of the testing done by our friends over at Magnum Engineering. They are a group of incredibly skilled electrical engineers who also manufacture PCB boards in-house. They are the ones who put this testing data together for us, and the final word in their report on this experiment is the following. The 3DP nylon had a surface resistivity that was immeasurably high, meaning that it had no ESD properties. Once sprayed with Lycron Crystal ESD coating, the nylon fell right in the middle of the ESD range, measuring at 10 to the 8th ohms. To summarize all of this, ESD-safe 3D printed components for your project can be produced with either MJF or FDM technologies. But no matter which way you go, you need to work with a partner who understands how to effectively print parts that can be used in this application. Here at Forerunner 3D Printing, we have done the research and development to not only be able to print your parts, but also test that they are indeed ESD safe before delivering them to you.